This is going to be the first video on solving trig equations at National 5 level. If you've not yet seen the video on the introduction to the cast diagram, please come off of this and make sure you get that down first, because that's what we're going to be relying on. Okay, so we've got three examples here we're going to work through. The first one is solve the equation sine x is equal to 0.6. And this notation just means x is in between 0 and 360. We're just talking about the one revolution of the sine wave. At National 5 level, you don't really need to be overly concerned about this. Just going to do a wee sketch here and just explain what we're probably expecting. So we're looking at sine x. So I'm going to draw a sine graph here. We'll just put in our information. So we've got a maximum at 90, a root at 180, a minimum at 270, and the first revolution finishes at 360. Okay, maximum 1, minimum -1. We want to work out when does our function sine equal 0.6. For example, see at this point here is equal to 1. This point here is equal to -1. We want to work out at what point or points does it equal 0.6. I'm just going to draw a wee dashed line across here. Hopefully you can see that there are 2 points where the curve is equal to 0.6. So we are expecting to get 2 answers. Okay? What we're going to do to start off with is we are going to draw our cast diagram. Okay, every trig equation question will involve us drawing a cast diagram. You don't necessarily have to draw the graph. I'm going to do it for the first couple of examples, but you don't need to. But always draw a cast diagram. Okay, so we go 0, 90, 180, 270, 360. They are all positive in quadrant 1. Sine is positive in quadrant 2. Tan is positive in quadrant 3. Cos is positive in quadrant 4. So, step 1, you always write down your cast diagram. Step 2 is you identify where is your function positive or negative. So, if we have a look here, we've got sine x, and do you see that this is equal to a positive number? 0.6 is positive. So we want to find out where is sine positive in our cast diagram. Okay, so what we do is we look at our cast diagram and we think, where is sine positive? Well, they are all positive here, so I can tick this one, because sine is positive in quadrant 1. In quadrant 2, S stands for sine, so sine is positive in quadrant 2. Sine is not positive in quadrant 3 or 4. In quadrant 3, only tan is positive. In quadrant 4, only cos is positive. So here, sine was positive, so we ticked the 2 quadrants where sine was positive. So we want to work out essentially what is this angle here and what is the angle here. And hopefully you'll notice there's a little bit of symmetry in the graph. For example, the distance from here to here is the same as the distance from here to here. And what we're going to do is we're going to use these properties of our trig graphs. So we've drawn our cast diagram, we've ticked what we needed to tick. The step now we need to do is we first find the acute angle. And to find the acute angle, to figure out essentially what the value of x is, we take the inverse of 0.6, sine to the -1 of 0.6. Okay, so that on your calculator that will be shift sine 0.6 and close the bracket. We generally work to 1 decimal place, so that's going to be 36.9. Okay, so what we have worked out, I'm just going to rub out these ticks here, put them a wee bit higher up. What we've worked out is that this point here is 36.9 degrees. Okay, so we've essentially worked out, I'll do a wee diagram here, is that from here to here we've went 36.9 degrees, but we also know that we've got this symmetry from 180. So I also know that I'll try that again a wee bit better. We also know that we've got 36.9 degrees coming back from here, because in quadrant 2 our answer should lie between 90 and 180, because we've got our first answer 36.9, but we need to find our second answer, which is in between 90 and 180. Okay, so what we do to find our related angles, for the related angles, we write down the quadrants where the angles are. So it's in quadrant 1 and quadrant 2. Quadrant 1, quadrant 2. In quadrant 1, our answer needs to lie between 0 and 90. Is this in between 0 and 90? Yes, it is. In quadrant 2, our answer needs to lie in between 90 and 180. Does this lie between 90 and 180? No. So what we're going to need to do is we're going to need to work backwards from 180 here. Okay, we always work from the horizontal line, so we're going to work from 180 back. So to work out x, we're going to do 180 subtract 36.9. 180 subtract 36.9, which is 143.1 degrees. Okay, initially this will be quite challenging because it's a wee bit new. Particularly using the cast diagram properly. That's probably the most important thing today that we can do. But essentially, our steps when we work through this: draw your cast diagram, tick the quadrants that you need to tick, find your acute angle, find your related angles. I'll do the second one a little bit quicker. Okay, question 2. Solve the equation cos x equals a half. So when is the graph of cos equal to a half? Okay, we'll just work through what I expect you to do in your jotter. Step 1, draw your cast diagram. 0, 90, 180, 270, 360. All positive in quadrant 1, sine is positive in quadrant 2, tan is positive in quadrant 3, cos is positive in quadrant 4. Okay, so step 1 done. Step 2, look at what we've got. We've got cos, and that's equal to a half. This is a positive number. Yeah, this is bigger than 0. So cos is positive. So I tick, where is cos positive? Well, look at my quadrants. They are all positive in quadrant 1. That means cos is positive in quadrant 1. So I'm going to tick that one. Is cos positive in quadrant 2? No, it's only sine that's positive in quadrant 2. Is cos positive in quadrant 3? Nope, only tan. But in quadrant 4, C stands for cos. So I know cos is positive in quadrant 4. So I know I'm going to get two answers. The first one is going to be in between 0 and 90. The last one is going to be in between 270 and 360. What we're going to do now is we're going to find our acute angle. To find our acute angle, we'll do cos inverse of 1/2. On your calculator, you should find that that is 60 degrees. We then want to find our related angles. So where are our two angles? Well, we've got an angle in quadrant 1 and we've got an angle in quadrant 4. Remember, it goes 1, 2, 3, 4. In quadrant 1, our angle needs to be in between 0 and 90. Is this in between 0 and 90? Yes. In quadrant 4, our angle needs to be in between 270 and 360. Is this in between 270 and 360? No, it's not. So we need to do a wee bit of work here to figure out what that angle is. So what I'm going to do at the side, I wouldn't not expect you to do this, is I'm just going to draw a wee cosine graph. There's 360, 270, 180, 90, 0, 1, minus 1. We want to work out when is it equal to a half. So it's equal to a half. Here, this isn't a very good diagram in terms of how I've marked it on, but you get the idea. So we've got these 2 points, but hopefully once again you see the symmetry. that from here to here is more or less the same as from here to here in my diagram? It is absolutely the case in the real graph. So what we do is I know that the angle from here to here being 60 degrees is the exact same as the angle that we're going to get here, backwards 60 degrees. Okay, so what we're going to do is we're going to work backwards from 360. We're going to do 360 subtract 60. And that will give us an answer of 300 degrees. Okay, what I'm going to do down here, I'm going to actually take a wee note of this. We didn't do this in the introduction to the diagram before, but I'd ask you to just take a wee mark up of this just now. See on our cast diagram, see to figure out the related angles. So what have we got? We've got quadrant 1, quadrant 2, quadrant 3 and quadrant 4. The angles that we're looking for, I'll just put this in as well, 0, 90, 180, 270 and 360. The angles that we're looking for can be found as follows. In this first quadrant, it's just the acute angle, because it's always going to be in between 0 and 90. In the second quadrant, it's going to be 180 subtract the acute angle. In the third quadrant, it's 180 plus the acute angle. And in the fourth quadrant, it's 360 minus the acute angle. And that's just all about the symmetry of the graphs. Okay, I'm going to do this last example quite quickly. Solve the equation tan x equals 7. Step 1, cast diagram. All sine tan cos 0, 90, 180, 270, 360. We have a look at our equation. Tan, this is a positive number. So we tick where is tan positive. Tan is positive here because they're all positive there, and tan is positive there. We find our acute angle. We'll do tan inverse of 7. On the calculator we should get 81.9 degrees. We then find our related angles. We have answers in quadrant 1 and in quadrant 3. In quadrant 1, the angle needs to be in between 0 and 90. Is this in between 0 and 90? Yes, it is. In quadrant 3, our angle needs to lie in between 180 and 270. This isn't in between 180 and 270. So we're going to work from the horizontal line, and we're going to work this way. Okay, so we're going to do 180 plus 81.9. That should be 261.9 degrees. Okay, and that's how we solve it. We're just looking at positives today. We'll build this up over the next week or so, but this is what today's work is going to be based on. Draw your cast diagram, tick where you need to tick, find your acute angle and find your related angles. Thank you very much.